Okay. So now we are doing this part of the sustainability portion, which is called as atom economy. What do you mean by atom economy? Atom economy is a parameter which is very, very importantly used in green chemistry. What is green chemistry? Now, every chemical reaction, suppose you want to get, suppose ammonia, right? There are many reactions you can get, right? A plus B gives you ammonia plus C, or you can use M plus N gives you ammonia plus C plus D, right? You can get many reactions by which we can make ammonia, right? Do you get my point, right? Or we can
Yeah.
have a reaction X plus Y hmm, gives you ammonia, right? So there are many reactions which can give you ammonia. But see, we have to think of the Mother Earth. Why? Because the products which you get over here, suppose in the first reaction you're getting C, in the next reaction you're getting C plus D, has to be disposed, right? Has to be disposed, discarded, right? Now, this might not be safe products to dispose, right? Suppose sulfur dioxide, right? If it came inside, it's not a
Yeah.
safe product, right? Nitrogen dioxide. These can give you acid rain. So there are many products where we have to dispose it of safely, or it is unsafe to dispose, or we have to dispose it with care. That
Yeah.
can hamper, or products which can hamper the Mother Earth, right? So can
Yeah.
we have a parameter? Can we have a parameter by which we can calculate that which reaction is the most suitable for preparing ammonia, which will be giving you least wastage? Number one. Number two, can we have some processes which best process you have to use where we can use a catalyst, or we can use less amount of energy to do this reaction? Did you get my point over here, right? So these
Yeah.
all comes under sustainable production. Sustainable production take care all the approaches we made to make our future generation more safer, right? Right, more safer on, they can use the resources, right? So we don't use the resources so that they cannot use it. So greener chemical industry, right? So that's very important, right? So this is very important, that the atom economy, right, atom economy will be telling us that which equation shall we use from this, which will be giving us less wastage, right? And if any waste product is coming up, is it hazardous, is it anyways hazardous? And if it is hazardous, can shall we treat it, right? So we talk about atom economy. This is a one part of the sustainable production. Did you get my point? So
Yeah.
can we take a reaction which uses less energy, or our energy bills will be saved? Yes. But we can calculate why atom economy. Now in atom economy, we have to understand that the formula is what? The atom economy will be the relative formula mass of the desired product from the equation divided by sum of all the relative formula masses of the reactant from the equation. Is it clear to you, right? Suppose you want to find out the atom economy of this, right? Suppose this question, right? This question. Suppose you
Yeah.
want to make PbO2, right? PbO, right? Can we calculate the atom economy? What the formula I told you? It is a percentage atom economy is the relative formula mass of the desired product from the equation. So this, right? Divided by the total formula masses of the reactant multiplied by the stoichiometry. Is it clear? Do you get my point? So what we
Yeah.
do, we into 100%. So PbO multiplied by the 2 means why? Because 2 stoichiometry is there. Divided by oxygen you take, right? Oxygen multiplied by 3, understood, right? And PBS multiplied by 2. Is it clear to you, right? Understand this part? Easy? This part is clear?
Yeah.
So this is the way we find out the percent at atom economy. So if you have got two equations to compare, go for a higher percentage atom economy. That will be ensuring less amount of wastages, which is there, right? And
Yeah.
it might be that the byproduct is extremely harmful. Suppose sulfur dioxide. Sulfur dioxide contains acid rain, gives acid rain, right? Isn't it? So that part also we'll be doing in the next videos, right? Clear to you? So this is
Yeah.
all about what? This is all about the atom economy. Yes. So we can also see that if we are taking this reaction, we have to dispose this safely, because it will be very harmful. How to dispose safely? We can use calcium oxide, right? To absorb
Yeah.
the sulfur dioxide. This gives you calcium sulfide, right? Isn't it? Calcium sulfide.
Yeah.
This calcium sulfide can be further treated with oxygen to give you calcium sulfate. And calcium sulfate C can be used to make plaster boards. Do you know what is plaster boards? Plasterboards is a duplicate plywood. We all have our wardrobes made by plasterboards. Do you get
Yeah.
my point? The
Yeah.
offices cubicles are made of plasterboard. See, we don't release it. We react with the calcium oxide slurry inside a tank, and we get calcium sulfide. Again, oxygen we add and get to calcium sulfate, and this is used in plasterboards. So this was all about what? This was all about the atomic